Well, I'm glad all of you could show up to this session. My name's 𝗦𝗲𝗀𝗀. I am the product owner of Azure AI Agent Service. And one of my favorite things to do when developing product is see what customers can actually do with it. Now, the Azure AI Agent Service is still in private preview. We'll be public previewing later in December. But that doesn't mean that customers haven't been building agents, and more interestingly, multi-agent systems. And so to show what he's built for his company, I'd like to invite Babak onto stage. He's a CTO of Cognizant. Please give him a big round of applause. Awesome. Thank you for joining us. I guess real quick, can you tease what you're about to share, and then I'll let you jump on the computer?
Sure. I'll give a little intro, and then I'll show how we use multi-agent systems to build multi-agent systems, and then I'll show the framework behind that. And we'll make sure that you guys also participate, and we spontaneously build some multi-agent systems. That's all I'm going to talk about.
Perfect. How meta. Well, I'll let you take it from here.
All right. Thank you. OK, to start, so my assertion is agents are the future. I think by now, being at Ignite, you all kind of agree. As far as a quick intro, I'm the CTO AI for Cognizant, where we are actually an AI-first company, and we're heavily investing in research and development around AI. We have a lab out in San Francisco and studios all around the world where we do innovation. We're measured by the number of peer-reviewed AI papers that we publish and patents. We work with academia, and we work with some institutions to build AI-based use cases, including AI for good use cases. So I have to put this plug out there for this AI for Good initiative that we are launching. Many of our partners and clients are already participating. If anyone in the room is interested, let me just give you a 1-minute overview of what it is. We started building these AI for Good applications after realizing that there are a lot of teams around the world that are trying to solve local problems that actually have global implications. We started with COVID. COVID hit everyone kind of differently, and all these local teams were really focused on fixing that. We have climate, you have poverty, you have water. There are so many issues that are global, but local teams are focused on it. And what we realize is that a lot of the data that they're collecting, a lot of the models that they're building in order to predict what's going to happen, and also to prescribe various different strategies to deal with these problems, can be ensembled into more powerful models that are better, more powerful than the sum of their parts. So what we're doing is we're creating a portal in which we define these problems based on the UN SDGs, and we get volunteers and teams and that are locally working on this. And we've also contributed IP to build ensembles of these models, not just to predict what's going to happen next, but also to come up with strategies to mitigate these issues. And then, of course, to be able to use it everywhere around the world. I mean, in places where they might not have the luxury of being able to collect the data or have data science and AI teams. So very proud of this initiative. If you're interested, please take a photo of this and contact us and sign up to help us out. But the real discussion, what I really want to talk about is agents. And everybody's talking about agents. So by now, I think you guys know exactly what an agent is. But what I want to do is level set before I jump into multi-agent-based systems. What is an agent, after all? Like, is it just another hype, like another way of saying LLMs, another way of saying deep learning, another way of saying AI is just the next hype? Well, there is a distinction. So AI models, large language models, generate stuff. That's why we call them generative AI. So they take some inputs and they generate outputs. They do this through a process of prediction. So to predict what we expect to see generated. So when you're using, for example, GPT-4 through Azure, if you give it a text command and it starts answering you and that answer looks right, that's because it's predicting what you might want to see in response to the query that you're giving it. So it's producing something in the output. What an agent does is it has a set of tools, and those set of tools allow it to do stuff. The brain of these modern day agents have been around since the late 90s, but the brain of these modern day agents are large language models. So the same generation that happens and the same smarts are transferred into an agent with this distinction that now what it generates could call for making a call to an API or doing something. And there's some code around that large language models that actually activates those calls and returns the response. And so we can iterate. So what does that mean? If we could already go to Azure ML and use, let's say, GPT-4 to write us code. We can already do that. That's a generative model. We give it a description of the code we want it to produce, and it produces the code. And if the description isn't too complex, that code is going to run fine. We just copy-paste it and run it, right? Now, what the agent can do with the proper tools is we give it the same command. It will write the code because it's using the large language model, but now it has access to a container, potentially. And it can actually run that code in a container, look at the result of the code. Maybe there's a runtime error, fix the code, iterate on it before it returns back the result. So right there, you can see that with the tooling that we're giving this system, with the brain being the large language model, the agent can do much more. The code could be more complex and more solid. And so that's the main distinction. Agents do stuff versus models just produce, they generate. And I think it's also important to note that this implies some level of autonomy. So the agent has to decide which one of the tools to use, when to use them. When it actually uses them, it's actually making a change in the world, typically. So yeah, if we run the code in a container, that's safe. But if we're actually running actual code that's hitting our systems, then that might be less safe. So we have to take care when we're building these agents because there's a level of autonomy and actuation happening. A lot of folks are announcing their agents now. You know, Salesforce is now Agentforce. ServiceNow has their own agents. These are typically ecosystems in which you can build agents. In other words, you can have a large language model. You can give it all the tools that it requires. And for example, with Salesforce, those might be tools that access Salesforce-specific backends. OK, now that we've kind of level set on what agents are, let's get to multi-agent systems. Gartner believes that it's the future. And you know what? As Cognizant, we agree with that. Not only do we agree with that, we think it's inevitable. We think a lot of our clients are starting to actually build multi-agent systems without knowing that they're building these multi-agent systems. We also think that leaving this to happen organically is probably not what you want to do. So let me get to that point. First, why do we think it's inevitable? Let me give you an example. This is a screenshot. Those of you in the audience who work for Cognizant will be very familiar. This is our intranet. We love it and we hate it. It's a collection of tools owned by different departments. You know, the finance tool payroll is owned by finance. I don't know, there's HR tools, there's IT tools, everything. But there's a collection in the intranet and it has a search box. It's very obvious that we want to replace that search box with some sort of LLM-based, augmented, maybe RAG-based system, right? So that instead of having to type in the exact keywords that pertain to the tool, we can express our intent in natural language, because LLMs understand language. So that makes sense. What doesn't make sense is if I have an inquiry like, I need Copilot for coding, and you know, the agent, quote unquote, that does the RAG search on my intranet identifies the IT app as the app that I need to talk to, for me to then have to go repeat myself to the IT app. Because guess what? That IP app is owned by someone else. It's owned by IT. And It has its own search box, and probably someone in that team is already replacing that search box with some sort of RAG-based agent anyway. So right there, you can see how obvious it is for us to want to connect these agents to one another. And how do these agents talk to each other? It's, again, really, we're lucky because large language models understand language. And so the communication between the agents could also be intent-based and language-based, which gives us some really interesting and powerful properties. So here you can see that Agent 1 got this I need Copilot for coding, and it said, it's talking to the IT agent, can you do this? And the IT agent is like, yeah, I can do this, but I need some information. What level engineer are they? Can we provision Copilot for this person or not? So that discussion happens. As far as the employee is concerned, they have this consolidated output, and they're only talking to one agent, so there's some discussion going there. But note that there is a level of encapsulation implied here. The one Cognizant agent that represents the entire intranet does not know what a copilot is, does not know that copilots are things that the IT agent might be able to provision. It's actually asking a question, right? So there's a level of encapsulation. And this is very, very useful. It's useful because it allows this robust sort of fabric of at least this intranet where if someone comes up with a new app, they can just plug it in without having to re-engineer everything else. And because the communication is intent-based, we don't have to, design and future-proof this thing ahead of time. So the domain of discourse can just expand and contract depending on what kind of application is available. Okay, so enough slides. What I want to do is actually show you this system. Let's take a look. I'm going to upload. I actually have the intranet agent uploaded here, and I can show you in our little agentic framework. You can see these agents. There's a main search box, and I have agents representing the various different domains. Each one has some downchain agents to it. And I can type in something like, our network is down. Okay, so what is that going to do? What's going to happen here, and notice I opened my coding thing here just so you can see that discussions are happening are in natural language between the agents. And agents are lighting up as they're being communicated with. And once we determine which agent or agents are responsible for dealing with this, we get a consolidated output that says, you know what, there's some issues here. And there's some networking issues that we can help you, so we can give you some support to get this back up. But your network being down is a security issue too. So we need to deal with that as well. So, okay, I was showing this actually, of all people, I think to Gartner. And they're like, oh yeah, what if there's a life change event? So I think something like my significant other passed away, would be another interesting query here. And it might be that, there's some legal advice that I need to get. There's obviously some benefits change, some payroll change that's going to happen. And you can see right here, I just typed this in, and I got this consolidated look. There's some legal considerations, and there's some HR and benefit considerations that need to go in here. And because of the encapsulation, and because the agents don't a priori know what downchain agents are responsible for what needs to happen, this can happen organically. Actually, someone just recently, I don't have their agent network, but someone recently said, hey, we have a lot of immigration-related queries that are coming into One Cognizant. We should add an agent for that. All we did is created that agent, connected it to the API within our immigration system, and plugged it in under HR. And now anything immigration-related can also be discussed, right? So okay, I think by now you kind of get a sense of how powerful this is, but I'll show a little bit more. Before I do that, though, so implications are also on software. So the way we start thinking about our application layer, about our software, should also change. And we should start thinking in an agent-based, a multi-agent-based manner when it comes to software modules. And so that's exactly what we did. What we did was we had, this is our flagship AI decisioning platform. What it allows us to do is build AI decisioning agent systems. A lot of our clients are moving from just getting insights from AI to actually making decisions augmented by AI. And so this platform allows us to build this. We announced this platform last year. And we started training our data scientists and AI experts and so forth on it. And we started on behalf of our clients using this as an accelerator for our clients. This year, we decided, you know what? We should eat our own dog food. If this software platform becomes agent-based, it has some very interesting properties. So that's what we did. So we added this whole Opportunity Finder pipeline as an agent-based augmentation of this platform. What does this do? So that's the question. When I get in front of a client, our clients are not used to thinking of AI as something that would help them with decision making. And therefore, knowing what kind of decisioning use cases can be built for them isn't second nature. And I don't blame them. We've always thought of AI and analytics as something that gives us the insights and then we make the decisions. So the first step shouldn't be asking the client, what do you want to build? It should be, who are you? And how can the agent help you identify the opportunities for making decisions? And that's exactly where we started. So we started, each one of these guys here is an agent that's augmented by a human, and we discuss with it as we build a use case. So I'm going to ask for someone in the audience, anyone, to volunteer the name of their company or their organization or some other organization they're interested in so that we pretend we're building them a use case here. Anyone? Yep. How do you spell that? I need the, I can't hear you, so, sorry.
Z-E for Eric.
Uh-huh.
N for neutral. S-A-I. 6 digits.
Is that it? MSA, or did I get it? Or?
Z.
Oh, Z.
Z-E-N.
Oh, 𝗬𝗲𝗀𝗃.
But the M is an N.
𝗬𝗲𝗀𝗃. Sorry, I'm deaf. Did I get it now? Awesome. Okay, 𝗬𝗲𝗀𝗃. All right. So what we're doing here is we're typing in the name of the company. Specializes in AI-powered learning. Awesome. Building an AI system for an AI company. Gotta love it. Hopefully it got the company right. And it is coming up with a number of use cases for 𝗬𝗲𝗀𝗃 that might be might help 𝗬𝗲𝗃 with their decision making. And it takes one of those use cases and it does an ROI analysis on it. It's the one that it believes will have the highest ROI for 𝗬𝗲𝗃. So first question to you would be, so I think it's employee learning and development is the one that it decided has the most bang for the buck. But I'll let you decide which one of these 5 use cases are more interesting to you.
Take the employee engagement.
Employee engagement. Great. Okay, so we're going to take this one. And now we move on to the scoping agent. So at this point, what I want the system to do is do a more detailed scoping of the use case for us, which means to identify what kind of decisions will help employee engagement, and what is the KPI? What is the outcomes? And it's usually more than one that 𝗦𝗽𝗀 should care about when it comes to employee engagement. So here, the outcomes that it's suggesting is change in engagement score. I'm assuming improving the engagement score, improvement in the employee retention rate, and cost. Because of course you can go out and pay your employees a lot of money and retain them and get good engagement score, but break the bank. So you have multiple outcomes here that are not aligned. Is this in line with what you were thinking?
I think it's flawless.
It's flawless. Wow, I love that. Okay. All right, so now we're going to go and generate 1,000 rows of data. And I'm going to ask now the data generator to do that. The reason I'm doing this is because obviously this is the first time I've heard of 𝗦𝗽𝗀. I have no access to their data. And what I want to do is rather than always kind of relying on an agent or an LLM's reasoning to help me with the decision making, where there is data, I want to make use of that data. And so what I'm doing here is I'm generating some synthetic data that is going to resemble the data that I expect to see when I engage with 𝗦𝗽𝗀. And it's actually building that use case with some synthetic data. It will build some patterns in that data for us to be able to find. I'm just going to take a quick look to make sure everything's okay. It looks good. And so now the other reason we're doing this is because it gives us a template. So now we have a data with examples of what we expect to be able to get from 𝗦𝗽𝗀 in order to help them with their employee engagement. And when we actually engage with 𝗦𝗽𝗀, we go and try to populate that template with the real data that they're collecting as they operate. So, okay, we're going to move on and say, create the use case. Make it explainable. All right, so I'm going to go to the orchestrator now and have the orchestrator build this use case for me. So remember, we identified use cases, we scoped it, we generated some synthetic data, and now what we're doing is we're actually creating the use case. So we have agents acting as data scientists and building this agent-based system for 𝗦𝗽𝗀 to use, granted running on synthetic data. Now, what is happening here? I showed you 4 agents so far. These are agents with human in the loop as we're interacting. We could have interacted more. We could have changed the outcomes. We can go back and refine this. It's fine. We could have started from the scoping agent and not even bothered with the opportunity finder. That's all good. But at this point, I have a set of agents autonomously working together to build the use case. And you can see as the system's reporting, as these agents are returning various different aspects of the design. But let me actually show the behind the scenes of this by loading the opportunity finder pipeline. These are the set of agents that are engaged in creating this use case for us. It's going to actually run the synthetic data code in a container, generate the data, put it on the cloud. It's going to do a description of the fields and pull that in. It's going to actually run a data profiler on that data set to make sure it knows what the ranges are, what the, median and statistics of the data is. It's going to look at contextual information and versus action information, which is the subject of the decision, as well as outcome information. That's the CAO. And finally, it's going to get to describing the project and actually building the experiment itself, which is happening here. So this thing usually takes a couple of minutes. As it's running, let me show you a few more examples of agent-based systems. Actually, maybe I'll ask the audience for other industries that they might be interested in seeing multi-agent systems in. IT services, yeah. I don't have that, but I do have telco. Let me show you this because it has an IT aspect to it. So here's a telco network, agent network. And there is a customer support rep, but notice that not only is it giving us, sort of support-related stuff, but it's also giving us, this telco happens to have a B2B business. So it's giving us that aspect as well. So a query to this one might be something like, our internet is slow, maybe because our team grew in, I don't know, Brisbane, grew to 100 members. Give me a quote for an upgrade, right? So that's, again, a complex query that's coming in, and these agents are going to talk to each other. And again, I just want to show you how multiple branches are going to get involved in trying to resolve this. And how many times have you called into a customer service rep and they put you on hold because some other customer service rep needs to talk to you, and you have to repeat the whole thing over to them again. And so this is an example of how this multi-agent system can resolve the query. And basically, someone in my team called it a silo buster. Like all these silos within our large organizations can be broken with this. And I think, so there's 3 different folks involved here, from the network operations, sales engineer, and project manager that need to help with this. Let's just check to see. This thing is still going on, so we'll give it another minute. Let me show you some. This one is a CPG company. So here's an agent network for a CPG company. And the reason why I wanted to show this is because it's starting to look like an org chart. So not only are we starting to look at multi-agent systems for software as an application stack, but as augmenting our organizations. And so that's why I thought I'd show you this one as well. Let's see, this thing is still running around. While this is working, I will show you another one that I built, because I figured it might be slow here and it might not complete in time. But let me show you another one I did. I asked the system, I think my initial query was Microsoft Ignite event organization. I did this right before getting on. And I picked, I think, marketing and promotion strategy. It did a scoping, wrote the code. So all those steps that you saw, I actually had it rewrite the code because there were some special characters. And I followed up and had it refine the code. And then it ran and built this use case. And the use case is right here. So what we're going to get, oh, yeah, we got this one. So I'll go back to that. This is the one for, so this just completed. I was going to plan B, but I can go back to plan A here. OK, so it actually created the use case that we were hoping for. It gives us a little disclaimer that all of this was put together by agents. I'm going to hit training real quick, because that does take a few minutes too. But I'll show you what the system has done. So we had a bunch of agents, you saw them. They came together, and based on the description that the other agents in the Opportunity Finder had put together, they built this system. And OK, there's a data source. There's some data. That's the generated data that we saw. And that data is now, we're creating predictor agents on top of that data to predict the various different outcomes: cost, employee retention rate, and change in engagement score. We have some uncertainty models so that if we're in unfamiliar territory, we can set a threshold and have a human come in and make the decision. We have a prescriptor that comes up with the decisioning strategy. What's amazing here is it decided which one of the KPIs is going to maximize, which one it's going to minimize. I didn't tell it that, right? So this was the reasoning of the LLM brain of one of the agents that said, you know what, here's how we're going to do the optimization. So at this point, we can make changes. We can add an activation LLM here so that we have sort of a chatbot-like interface as well into the system as it's being picked up. You can see it did get picked up and it's being trained. This will take like a couple minutes. Once it's fully trained, we can see it. In the meantime, there are other agents involved here as well. Had I not generated the data synthetically, I could have added, for example, a category reducer so that unstructured data can be classified in various different ways and structured and pulled in. If there's missing values, we can actually have an agent that confabulates the data for us. There's an agent that we can use to interact with the data. My little parlor trick here is I ask it to create a useful chart. Useful being, defined by the agent. I don't know what it's going to come up with. But this is a chart. I mean, you can tell me if this is useful, but based on department, it's telling us what the engagement score is right now. And it seems like your finance department has some issues. Anyway, okay, so that's, we can also, what's amazing here is that we can actually use an agent to check this design. So let's have an agent analyze the entire design. That, mind you, was put together by other agents, so I don't mind it criticizing it. And it will give us some feedback, some recommendations. Here it's, for example, here we go. It's giving us some recommendations, some pretty detailed recommendations as to what to change to make this design even better. Okay, hopefully we're at generation 9. Another 4 or 5 generations and this will be done. And I can demo the completed version. This is a no-code platform. So this whole pipeline of taking the data, prepping it, creating predictors, creating uncertainty models on the predictors, creating the prescriptor and against this digital twin, and adding the activation LLM. All of this will be generated as a notebook, as a Jupyter notebook, kind of similar to this one. Similar to which one? So one of these, for example, where you can actually see the actual Python code around it, where to actually load the source file, or if you want to redirect it to a different source. Everything here will be captured in a notebook as soon as this training is done. There we go. This training is done. I can actually download the various different artifacts, run them where the data is, so you don't have to move your data over, and so forth. Okay, so let's take a look at the actual system. It's telling us how well it's able to predict by mean absolute error, the various different KPI that we care about, employee retention rate, how well are we able to predict that, how well are we able to predict cost. It gives us the art of the possible. This is really important. Like, given the data, how much can we actually impact the various different KPIs? So we can see here the change in engagement score. Retention is improving, and cost is actually decreasing. So that's good. We're in a good place. Now we can actually, obviously this is multi-objective, it's multi-outcomes that we care about. So we can actually see each AI that is the best at some balance of the 3 KPI. Sorry, this doesn't quite render well, but change in engagement score, employee retention rate, and cost. So we can look at this and select which AI we want to use right now. Like if cost is less of a consideration right now, you're a startup, you're growing, you do have the investment, maybe you're taking one of the agents that are less sensitive to cost but more sensitive to employee engagement. Another way of doing this is to view it in parallel coordinates, with each line here being an AI system. And I'm assuming engagement rate is the most important, so we'll pick anything that has greater than 0 engagement rate, and then pick the ones that have the best employee retention rate, and of those maybe pick the one that has the least cost. So depending on which one of these we pick, we can go in and interact with it. So there's this placeholder UX that it generates. Obviously, the end system is going to look better and will be maybe part of, integrated into your Power BI, whatever else. But you can run what-if scenarios here. What if I have this employee that's a little older, here's some information about them. What should I do? So that's basically what we wanted to create, an agent that would tell us what to do. So let's do a custom initiative on a monthly frequency company-wide with adding a suggestion box, blah, blah, blah. So it's giving us some suggestions, and it says if you do so, here's what you're going to see: the change in engagement score, the employee retention rate, and cost. And you can always, so if you remember, I asked it to explain itself, so we can ask it to explain why it thinks we should do this. We've used an inherently explainable model for the decisioning strategy, but we can run that through an LLM because reading these rules is going to be harder. And it will give us an English language explanation of why we should do what it suggests, and then it also does some risk and bias analysis and gives us some mitigations. Okay, so with all of this, we also asked it to add an activation LLM, which is the front end, so we can actually talk to this thing. So I can say, how can we improve engagement rate even more? And so this agent has those tools. It has the predictors, the prescriptors, the uncertainty models, and it's going to make those calls as well as taking all the information that was already in that form, and it's going to come back to me and say, here's what you need to do to improve engagement scores. Now, this is running in developer mode, so you see sort of the innards of how it thinks and how it's making the calls, but it will highlight the response in natural language. There we go. So you can see now I have this decisioning agent network that was automatically created by other agents. We created in what, like 10 minutes? And we can plug it in to the other network that might be our organizational agent network. And so that we have a single entry point, and if there are cases where these decisioning are hitting other agents within our network, it can actually make use of that as well. Okay, to wrap up real quick, maybe I'll go back. I realized there was another use case too. We can get to that maybe if you guys are interested later, but I think I hit everything I wanted here. So I'm going to go back to my presentation real quick. I can find it. And just finish off with a few quick slides. One is if you are interested in us building these types of use cases for you or giving you a live demo with our team, please take a photo of this and get in touch with us. The obvious question is, have you used this? And the answer is yes. And we've not only used it with clients, we've actually used it internally. Here's one agent network that we use for our RFP pipeline. It's called WISE. And a bunch of agents come together with some manual steps from the moment the RFP comes in to deciding whether or not we want to even respond, all the way to building the response itself. So yeah, we can help you identify your business. The good news is that we have Azure to rely on with all their agentic platform available as well. We're not a product company. Cognizant does not reinvent the wheel. Everything you saw sits on top of cloud providers, hyperscalers of your choice, and benefits from that. The other thing I want to say is that these systems, we can use it on your behalf. We actually created it as an accelerator, so we can use it on your behalf to create these use cases. Or the good news as of last month is that the entire platform can be run on your Azure instance or on-prem for you as like an idea generator, as a factory to build these use cases. So again, if you get in touch with us, we can walk you through how we can get that done. And yeah, this is just, I'm not going to read the slide, but this is our overall sort of suggestion as to how to not leave this to happen organically. But just to give you one last cautionary slide on agents. If you remember, we started off talking about agents saying there's a level of autonomy that these agents have, and they can make some decisions on our behalf. So actually, my colleague Abe is here. Together, we came up with this do's and don'ts list of how you create an agent, especially agents that are more critical in your decision workflow. So let's start off by assuming that the agent will have a percentage of time that it is going to make autonomous decisions. That's the reason why we're agentifying anyway. If we make that assumption, the counterpoint to that is there is a percentage of times where we don't want it to make autonomous decisions, which means let's explicitly list and hopefully be able to come up with rules that tell us when is this agent not allowed to autonomously make a decision. So that's step one. Step two is there are methods now, and my lab also has a library around this, to assess certainty, or more technically uncertainty, on the output of large language models. Remember, large language models hallucinate, and they're scary. And, okay, so we can actually rank order outputs of a large language model based on how certain or uncertain they are, and pick the ones that are the language model is more certain about. So that gives us the ability to actually set a threshold and say if it falls below or above a certain threshold of uncertainty, we want a human in the loop. So that's step two. Step three is, as I showed you, we can actually have these safeguard agents that sit side by side your agents and check the input, the output. Everybody does this for more sensitive systems, and we should do that for more sensitive agents to check their operation, and if needed, either stop them or pull a human in. And finally, this is also something that we advocate, is a disengage button. So thinking about having a disengage button makes you really consider all the risks of agentification as well. What do I mean by a disengage button? This is that big red button when all hell breaks loose in your organization because a lot of autonomous decisions are being made. You hit that thing and everything drops down to rule-based, consistent operations until you figure out what's going on. Remember, all these agents are logging their behavior, their reasoning in natural language. You can very quickly identify what's going on and fix it if there's a problem. But just thinking about multi-agent systems as having a mode in which you can disengage the LLMs, it gives you the safety that your system has a mode to go to that's more reliable. With that, I think we have around 3 minutes left. I'm going to stop right here and answer any questions that anyone might have. You have a question. Or you have a question. Go for it.
Did you train all those agents on your data? Because as you mentioned, the infrastructure is all Azure. So how did you build up, for instance, your policy systems and stuff? So you need to train it on your data.
When there is data, we build agents that are trained on the data. Where there is no data or the agent is part of a fabric of a multi-agent system, we can prompt engineer the agent, or after use, collect data and fine-tune the agent on its operations. It doesn't have to be really trained on data right off the bat, as long as we give it the confines of its responsibilities and how we want it to act, and the tools for that particular sort of system it's representing. So not always. You don't have to train it always. But the system that I just built for 𝗬𝗲𝗀, clearly there were steps there that had to be trained on a real data set. Any other questions? All right. Thank you very much.